Hey there, hope you're having a great day. And in this video here, we're going to talk about the node class. Remember, the singly linked list is just a collection of nodes that point to each other. So before we can even attempt to do a singly linked list, we need to create the node class that has that behavior. This is the actual code, what it looks like. You notice we just have our constructor here. Oops, let me bring up my drawing tool here. We have a class node. And it's basically got a constructor here, which just requires a data property to be passed in. And we're creating two instance variables. So underscore data. Okay, the underscore just means, hey, it's a Pythonic way to say, hey, this should be private variable to this class. We don't want to allow people to directly access this property. So you just throw an underscore before it. Python underneath the hood doesn't stop people from accessing it. Like some other programming languages will have actual private instance variables that won't allow, will throw an error if it's accessed from outside of the class. But Python doesn't have it, so we just kind of try to replicate that behavior this way. So that's all the underscore means. It's just going to be private to this class. And we're going to set that to whatever's passed in on the constructor. Then we have the underscore next, so the private instance variable next. Again, that's going to be our pointer to whatever next node. When we first create a node, we don't know what the next node in the list is going to be, so we just default it to none. Now, because the data and the next instance variables are private, or in theory they should be, even though Python doesn't enforce it, we need to expose some methods that allow people to interact with it. So that's what these are. These are my getters and my setters for the data property, and these are my getters and setters for the next property. All these do is expose methods that allow access to those properties from outside the class. And that's just kind of a more cleaner way of doing it, of interacting, allowing the interaction. You're defining, when you create this class, you're defining the behaviors or the interactions that you are allowing this class to have. Okay, so because this data variable, instance variable, is private, or should be, I need to expose a property that allows someone from outside the class to access it, as well as someone from outside the class to change it. Same thing with the next instance variable. It should be private because it's that underscore. So we're going to expose a method to get the next property, and then also to set it. That's all those are. Pretty simple implementation there. And there's different ways to do this. You may see in some videos someone, instead of having to get data, they'll kind of have like a property there, and then they'll have something like this that says data.setter. You can definitely do it. That's kind of a good Python way of handling that, but I didn't want to get that much in depth in this video. I don't know what everyone's experience with Python is, and I don't want to get that advanced. It's easier just to say, hey, get data as a function, set data as a function. Here's the sources. Look for the slideshow here in the video description. The code from the Project Full Stack GitHub. Wikipedia, I'm actually not going to use it in this one, but you can look at it if you want for more information. And then Big O Cheat Sheet, Visual Go. So what are we doing here? We're creating, we know a linked list is basically a collection of nodes. Well, before I can even attempt to make my linked list, I need to create all these nodes, or some way to handle creating these nodes. So that's where the node class comes in. What is the node properties? The data and the next. Data can be any basic data type, like strings, integers, floats, booleans, whatever, or more complex data types. So you can throw dictionaries, lists in here, tuples. You can even throw other linked lists in here as the data. It really doesn't matter. It's whatever you want your node to hold. And then that next, which is going to be a pointer variable to the next node in the list. So let's go ahead and create that. Let's pause video here. Let me bring out my editor. All right, I'm going to use test-driven development here. So basically, I'm going to write some test cases first before I do any code, and then I know my test cases are going to fail, and then I'm going to write the code until it satisfies the test cases. So that's called test-driven development. For this kind of class, it seems pretty silly to do it, just a simple node class with a constructor and a couple of getters and setters. However, this is going to become very important for the rest of our data structures as we write new functions. We need to be able to test them and make sure they work. So it uses the unit test, which is a built-in Python module. You can go read more about it if you want. I'm not going to go super into depth here. Feel free to copy and paste this if you want, or you don't even have to bother with this test class if you don't want to. But I'm just going to create some new test methods. Basically what I want to do is I'm going to create a new node. So node 1 is going to equal to create an object of the node class, which I haven't even created yet, so I know this is going to fail. But it's going to have a property, or its data is going to be 17. Then I'm going to run some tests here, and I'm going to say self.assert equal. I'm going to pass in what I want, which is going to be node1.getData, which should return 17. So I'm going to say it should equal 17. Now I'm going to say self.assert none, which is going to be node1.getNext. And that should be none. Because remember, when we first create our node class, as I pass in the data to the constructor, it should set the private instance variable underscore data on that node class or that node object, and then I can get that information using the get underscore data function, and it should return 17. Same thing with the next. Next should default to none, and I use the get next function to get that. So if I come in here and let's see where I am, linked lists, make this a bit bigger here, Python. There you go. So now I can run it by just saying test.py, and it's basically, let's see here, something's broken. I think I didn't save it. Let's try that. This is in, I wrote that all in the node class. So here, let me just copy paste this into the actual test. There we go. Now this is going to work. So Python test.py, cool. It broke, which is what I expected. I knew it was going to break because we're trying to import this node class up here. I haven't even created it yet. So test-driven development, I write my test cases first. I know they're going to fail or break, and then I write the code to fix it. So now let's go in and write our node class. Class node. All right, and let's just do a pass statement here. Run this again. Make sure that now the import works in my test. All right, cool. So imported worked. We came in, we ran this test case, but then it failed. So let's look at this. So it failed here in test node init. Node 1 is equal to node, and we're passing in 17, and it basically says node takes no argument. Well, that's just because I haven't created the constructor yet. So let's go in here and let's create our constructor. Instead of this pass, let's create our constructor. And we basically said it needs to take some type of data in as a parameter. And then we're going to just set the private instance variables. Remember, the underscore is just, instead of saying self.data, I'm going to say self.underscore data. So a little Pythonic way to say, hey, this should be a private variable. That's going to equal to whatever we just passed in. And then we also needed to do the next property. And that's going to default to none. All right, so we run our test again. And we're getting closer. Now we're on line 12 in my test. So we're right here. It's saying node object has no attribute get data. So we haven't created that get data function. So let's create it. And again, all these are our getters and setter methods that allow interaction with our class from outside of it. They're nothing fancy. Like get data is just going to take the normal instance variable first, and it's just going to return self.underscore data. Make sure you have the underscore in there. Okay. So there's get data, and let's just do our get next as well, because we know that's going to come up here in our very next line in our test. So we may as well write that now. So get next, and that's going to return self.next. All right, let's run our tests. We're still getting an error. Has no attribute assert is none. Is it assert is none? That's what it is. It's going to assert is none. That's the actual method I want. That's just on the unit test module. If you're not doing the testing, you don't care about that. But cool, now our test ran. That's great. Now we just need to be able to test the getting and setting the data. So let's just call this test node setters. Gonna take in self. Again, I'm just writing the test case first. If you don't care about the test unit module, you don't have to do this. We're basically gonna copy this. And let's make a second node too. Well, we'll do node 1 first. Now I'll create a second node down here, which is gonna be node 2. And that's gonna have a value of 23. We don't really care about these assert equals for get data and set data, but now let's do node, well, let's do this. Assert equal node 2's data should be 23. Now let's change it. Let's say node 2 dot set data, and now let's say 99. Then let's say self dot assert equal. We'll still say node 2 get data, but now since we changed it, its data property should be 99. Now the next thing we have to test for the setters, we tested the set data, so let's do the set next. So let's say we know this. Let's do this. This is going to be the test setter for the data property variable. And let's test setter for the next variable. All right, so I know the node 2, let's test it first, that the node 1's next property is none. Now let's change it. Let's say node 1 dot set next is going to equal to node 2. Okay, so I'm setting the next property, I'm passing it the node that it's going to point to, and then I just basically need to say, let's say self.assert equal node 1 dot get next, yep, is no longer equal to none, but now it should be equal to node 2. And let's also just verify that node 2's next property is none, just to make sure we don't do something weird and for some reason set all the next properties on all the instances of our class to none. So that's node 2.getNext should be none. All right, let's run this. Created our test cases. Has no attribute set data, the node object. So go into node, let's do it. All right, we'll do both our setters here. So set data is going to take a parameter called data, and it's going to say, hey, take our instance variable underscore data and set that to whatever we passed in here to the function. Let's do the same thing for set next. Self.underscore next is equal to whatever we passed in here for this setter method. Okay, now let's run our test here, and bam, all our tests pass. So this is our node class, and we've actually tested it. So now the benefit of testing, if you haven't done test-driven development, now maybe I come in here and I mess my code up at some point. I'm not paying attention, and for some reason I do something silly like this. And then I run this again. It's instantly going to tell me, hey, here's what's failing from all your previous test cases that passed. We got 2 failures, and we got here's where it is, so on and so forth. In terms of the node class, it is kind of silly. I agree to kind of do your test-driven development here. However, it is good, and it is going to be good practice going forward with the rest of our data structures.